Hello Gators, this is 10-1, Arcs and Sectors, Day 1. I can find central angle, intercepted arc, major arc, minor arc. Let's talk about what a central angle is. A central angle is made up of two radii. This angle is made up by that two radii, and this is a really important, I put triple stars here. This angle, which we call the central angle, is also the measure of this arc. This is the arc. They are the same. They are equal to each other. So if this arc is 82 degrees, then the angle is also 82 degrees. They match. Now remember, all the way around the circle is 360 degrees. This is only part of the 360 degrees. Let's take a look at some vocabulary. We are calling this the central angle. The arc that's inside, the part of the circle that's inside the angle is called a minor arc. The rest of the circle is called the major arc. It's important to always label the minor arc with 2 letters, the major arc with 3 letters. There is also a very large arc called a semicircle. Arc E, G, F is half a circle, and half a circle's measure is 180 degrees. Let's go ahead and practice. So we would like to find the measure of this arc. Remember, the measure of the arc is closely associated with the central angle, which is 80 degrees. So this angle is 80 degrees. Anytime I want to find the measure, I have to use a little m to remind me measure. Very similar to when we were working with angles. Angle, N, R, M, we would always put an M in there, and then we would say, hey, it was 80 degrees. We're doing the same thing with arcs. We're using the little m to remind us it's a measure. It's the number of degrees. Now we'd like to figure out M, P, we're going to go in the P direction all the way to N. Well, that's the leftover from 360 degrees, because all the way around is 360. We subtract 80, and so we're going to get 280 degrees. And that's the leftover right there. Okay, now we'd like to figure out what P, over here, P, M, N is. And remember, this is a diameter, and diameters like to cut things in half, circles in half. So that'll be 180 degrees. Let's talk about arc addition. Very similar to when we did angle addition, little plus little equals big. Well, we can do the same thing with arcs. The big arc will equal the little arc plus the little arc. I'm going to use this in the next problem. All right, so I'd like to figure out what GE is. Here's GE. And GE is made up of 2 arcs, GH, which I know is 40, and HE, which I know is 80. So altogether, that arc is 120 degrees. Now I'd like to figure out what GEF is. Well, GEF is made up of GE, which I already found was 120 degrees. And now I just got to add this EF part to it, which is 110. And so the answer will be 230 degrees. Now I'd like to figure out this arc right here, this arc right here. And this is the leftover. I've already figured out all of this arc right here. It's 230 degrees. So this is going to be the leftover from 360. 360, take away 230 degrees, and the answer is 130 degrees. All right, let's take a look at an interesting situation. This central angle is 45, so the arc is 45 degrees. This central angle is 45, so this is 45. So what we're finding is that these 2 arcs are the same because their central angles are the same. This is going to happen here too. They're both 80, so these arc measures are 80. Look at this. This is really interesting. This central angle is 65, so this is 65 degrees, and this is 65 degrees. I want you to notice that their measures are the same, but their lengths are not the same. This is going to be important on the next lesson. They aren't going to match each other, but their degrees match. All right, let's go ahead and do some algebra. We want to solve for x, and we can see x is right here. And I want you to notice there's 1, 2, 3, 4, 5 arcs. 1, 2, 3, 4, 5 blank spaces, and they all have to add up to 360. So the way we solve the problem is we put all of the arc measures inside and then solve and get our answer. Let's take a look at another problem. We're going to assume that lines that appear to be diameters are actually diameters. These red things look like they're diameters, so they are diameters. All right, now to solve this problem, I'm going to notice that this this angle and this angle right here are vertical angles. Remember when we have two lines like this, that those opposite angles that are occurring like that are vertical angles. So I can use what I've been learning from last semester, and I can set this arc equal to the other arc, or I can set the central angles equal, whichever way you want. So it's going to look like this. We know that if this arc is 66x plus 2, so is the angle. 66x plus 2 is this angle. So this whole angle will equal this whole angle right here. And so I'm setting them equal to each other, the two angles equal to each other, and then I go ahead and solve. So in this lesson, we learned about central angles, and we learned that central angles and the arcs are exactly the same, and we learned that the number of degrees in a circle is 360, so we can find leftovers. We can add arcs up together and deal with it that way.